you should have seen before. So
minus 3 and 4.
minus 3, so it's minus 4 and positive 3 to get the negative 1 there.
Oh yeah, get that negative 1. Yeah, I'll give you.
Okay. Now, that's it for that one. Totally done. You do not have to solve it, just list a factor. Factor does not mean solve. Number 2, what is the GCF? What is the number or the letter that goes into both?
Be 9.
9, and then P to what power?
P to the third power.
5.
Actually, no, 5.
5.
Yeah, because
So P squared minus 4.
and P to the. So that's a perfect school. Or,
So this can be factored further.
yeah,
This is
the
difference of
factor. Yeah.
squares.
So 9p to the 5th, p plus 4p minus 4.
What did you say? I'm sorry, I didn't quite catch that.
P plus, here, let me see. Yeah, p plus 4 and p minus 4.
Okay, so watch this. When I FOIL this, I get P squared minus 4P plus 4P minus 16. Does that get us back to the original?
No.
No. So what is you're missing a little thing. Why did you put P and P? Because it's the square root of P squared. You've got to take the square root of 4.
Oh, yeah,
That's
right.
the
Then it'd
difference of
be p
squares.
plus 2. Yeah, because
Yeah.
it's technically 2
Right.
squared.
And you don't have time to FOIL and multiply, but that is the way to do
So
it.
maybe
If
the
you,
better way to do it is probably to rewrite the second step and then write 9p to the 5th p squared minus 2 squared, like in the middle there, maybe.
that would be good. That would be good. Yeah, we'll do that here, or you can do that on your own. All right, so the last one here on the right, what is the number or letter that goes into both?
About, think, say 3, 3. Actually, wouldn't it be 3 n to the 4th?
So that's n squared minus 11 n plus 24. Then you have to factor that as well.
But yeah, 3 n.
What does that factor into?
I got negative 8 and 3, so I'm plugging them. So,
Yeah,
that's
so
gonna be
n
fine.
minus 3, n minus 8, and that's it. You got it.
All right, yeah, that's good now.
All right. So go ahead and send over some more stuff, or if you need me to, I can make up more like this, but good smattering of questions here to think about.
All right. There's another one I want to go over. It's the same directions as that one, that was number 4.
There it is in the chat. All right. So again, there's a GCF here. What's the, forget out the 4. That's not part of it. What's the GCF here?
2.
N with K?
And then k would be k to the second, k squared basically.
So 2K squared, and then tell me what goes in parentheses here.
Parentheses, you would put k squared minus 121.
Good. And
Yeah,
then this is difference of squares.
so that would be 2k squared, k squared minus oh k squared minus 11 squared. That would be 2k squared k plus 11. All right. The next one I have a question about, like
Sorry, you have to figure out the number that goes into 54 and 16 on this one. It's not a perfect number. 16 does not go into both. So what some students do is they just sort of guess, like, is it 2? Is it whatever? But you really want to look at the smaller number and look at all the factors of 16. 1, 2, 4, 8, and 16, and figure out, well, what's the biggest one that goes into 54? Like 2 works, but does anything bigger than 2 work? Are you still with me, Karthik?
yeah.
Okay, it is 2. It is 2. So it ends up being 2w to the 4th. Tell me what goes inside parentheses here.
That would be 47.
27.
and be 27 W to the cube, W cubed,
Yep, minus.
minus 8.
All right, good.
Yeah.
Now this is difference of cubes. Difference of cubes. So this is an a cubed minus a b cubed situation. So you have to figure out what is it cubed, what is it cubed that gets you back to the original.
So in this case, A is already cubed, but
Well, the
B,
W is, but what about how do you get to 27?
uh,
And you're cubing this time.
3 cubed.
3W, yeah. And then how about to get to 8?
To get to 8, it would be 2 cubed.
It is 2 cubed. Good. So your A is 3W and your B is 2. Is that okay?
Yeah.
So the formula for A cubed minus B cubed is A minus B times A squared plus AB plus B squared. It's yet another thing to remember. So for you and your problem, it's 3W minus 2, that's the A and the B, parentheses 3W squared plus 3W times 2 plus 2 squared.
All right, and it's A squared plus AB plus B squared plus W squared.
So you do have to simplify, like you have to say, okay, it's 9W squared plus 6W plus 4, 3W minus 2. And then you have to be like, oh yeah, don't forget that other little piece, that 2W to the power of 4 there. Karthik, what else would you like us to work on here?
What was that?
I'm just sort of in being patient here, but I'm still here. We got some more questions or some other stuff.
Um, yeah. Some of the questions I have on that uh, lesson. Other than that, I think I'm gonna try to every other question on there.
I'm not hearing you very well. It made it sound like you're a little bit far away from the microphone.
So I think I had that one.
There you are. I can hear you now.
Yeah, so I think I finished all the other questions on like the front and everything with that homework sheet. So this is the next lesson, uh, 4.4. I think it says solving the polynomials by factoring.
Okay. So there's a big relationship between what we just did and this new stuff. Basically, it's you're going to factor and then set them equal to 0. These are both considered higher order factoring problems. So they're maybe a little bit different. There's two ways to do the problem on the left. One way is to just be okay with the idea that it's an x squared factoring. Um, some students make a substitution. Let me just cross this one out for now so we can look at that later. They'll sometimes do a substitution like u equals x squared, and then u squared is x to the fourth. And so they rewrite the original as u squared plus 5u minus 6 equals 0, and then they factor it the same way that they do other problems. The thing is, when you back substitute, when you put the x squared back in for u, you end up getting the same thing you would have gotten in the other one. So it's kind of up to you. Like I don't have a preference, but
Yeah,
you
it seems
might
to be
see
the
this
same. It
kind of
seems to be the same exact thing, just in a different way.
yeah, yeah. Now you keep going. It's not a stop. It's okay. There's more to do here. The one on the left is not factorable. X squared plus 6, there's nothing more that you can do there. the x squared minus 1 is difference of squares. So that becomes x minus 1,
So
x plus 1 equals 0. You set each of these
equal to 0.
equal to 0.
So that would give you. Wouldn't
So
you also
x
set the
is
x squared uh, plus 6 equal to 0 as well?
so that is up for debate because it doesn't have any real solutions. And your teacher's making the classic uh, teacher mistake here of not telling you what the domain is. Are you in the real domain or the complex domain, or both? Um, yeah, you can set it equal to 0, and then you get x squared equals -6, and then when you solve for x, you
You
get
get x equals
plus,
6 high. Or,
yeah, plus or minus I square root 6. So I don't know.
uh,
You
all right.
that's a great question to ask in class. Like, hey, are we in the real domain or are we in the complex domain or are we in, you know, what do you want me to do here? And they should be able to tell you that.
Got it. So basically, this is factoring it and then setting equal to 0, then equating each part of
Yep.
the equation to 0. Got it.
Now the second one is difference of cubes. So number 2 here, x cubed minus 216 equals 0. This is difference of cubes. There is a sum of cubes also, which it's very much the same formula. A squared plus AB plus B squared. So sum of cubes, which this is not, but I might as well put this in at some point. It's really similar. All right. So the this becomes x cubed minus 6 cubed. And it's like you said, it's good to take one line and rewrite it.
Okay. After that, you would get um, 6 and x squared minus 6x plus 6. Oh, in this case, you're not multiplying both those by another number outside.
So
So
you're still saying it equal to 0. So the first one you said equal to 0. That's great. That's just 6. The second one is always, always, always quadratic formula, and it does not have any real solutions. So that's another one of those like, well, do I need to do it or not? I don't know.
So that means that in this case, like A would be -6, B would be 6, and C would
Yeah,
be 30.
C is 36. So it ends up being 6 squared minus 4 times 1 times 36 all over 2 times 1. So it's you know it's not great. Uh yeah, I mean you get -6 plus or minus the square root of -108 over 2. So -6 plus or minus, so 108, yeah, 2 and 54, 2 and 27, 3 and 9, 3 and 3. So it ends up being a pair of twos and a pair of threes come out. And then you divide each of these by 2.
So I'd like to go over this question. I think it's pretty close. Actually, I think it's pretty close.
Okay, so you sent over something else. Take a look. So you can see a lot of this is like really you're doing a lot of repeat of what you previously learned. So this is again another example of a higher order factoring problem. And there's a couple of ways you can do it. I think the best way is to make the middle variable the u, and you'll do this again in math. You'll do this up through, you know, partial differential equations as high as you can go in math. You'll just, this is a common technique. You square it is the next technique. When you square x cubed, that becomes x to the sixth. So it becomes u squared plus 19u minus 216 equals 0. All right. And now you have to factor this, which, yeah, it's kind of a pain. 3 and 72, 4 and 54, 6 and 36. Does 8 work? Yeah, 8 works because 2 and 4 work. So it's 8 and 24. No, that doesn't seem right. Um, yeah, this is where it gets kind of like nice to have a calculator. 27, and that's the one. That's the one there. So it becomes u plus 27, u minus 8. And then you have to back substitute. So whenever you make these substitutions, you always have to remember to back substitute. So it's x cubed plus 27, x cubed minus 8. And these are both cube problems, sum of cubes, difference of cubes.
Got it. So from there, you just have to use the a minus b and then the a squared minus plus 2
Yeah,
or
and
plus
there's a fair amount
ab.
of work to do here. It's not um, so I don't know how comfortable you are with this. It would become x plus 3, x squared plus 3x plus 9, x minus 2, x squared plus 2x. Actually, sorry, this middle one is a negative. Whoops. Um, plus 4. And then that's where, I mean, I personally don't want to do it, but do you think you're going to have to use quadratic formula on each of these?
Oh yeah, yeah, right. But wouldn't you? Oh, actually, never mind. Yeah, you said x plus 3 equal to 0 and x squared minus 3x plus 9 is what you'd use the quadratic formula for.
Yeah, you set them all equal to 0, and there's a lot of work still left. That's why I tell students, work as hard as you can in the earlier sections because it just gets worse. It's just more involved. There is a pattern to these, by the way, which we should talk about as a shortcut to them. But I don't know if you want to do that now, but we should at some point talk about it.
Yeah, because I did see earlier today on the Google Classroom that she posted the entire schedule for the chapter. We do have a quiz coming up on 4.1 through 4.5. So I think we're doing 4.5 tomorrow, or not tomorrow, Monday. So we have a quiz next Tuesday on everything we learned so far in this chapter, and then 4.4, which is what we're doing right now, and 4.5, which we're learning on Monday. So yeah, it's probably certainly we're doing it. But, yeah.
They just kind of get overwhelming. 3i over 2 square root of 3. 2 root 3. So it becomes I squared 3.
Wouldn't the one on the left be 3 plus 3i over 3? Simplified that way, actually.
Square root of negative 27 is 3i root 3. So that's where it goes in the top. Yeah, so this is negative 27.
Oh yeah, never mind. I was thinking
Yeah.
something else.
Yeah, I do make mistakes, so please double check me. And if you see differences, made a bunch earlier with a statistics class that was by hand rather than software. It's kind of worse than this.
So I'm thinking the other problems on 4.4 are mostly the ones with the four terms that you have to basically group it and then
Okay.
do that.
Grouping's a challenge.
Let me go ahead and do it one of two. Let me see. Yes. All right, that was it. So this is number 5 on the. Oh wait, did oh, put the same. Here it is. Very well. So for this one, wouldn't you just have to group it and then uh
Let me get it up here. I
yeah,
just
then
saw that it
sum
came in.
that
I'm
up.
sorry. It was yeah, you're gonna use grouping. So, and hopefully it is a grouping problem. So you take the GCF out of the first two, and then you put what's in parentheses for the next two, and you hope that it works out. This one does. Like if you multiply -8 into both of these on the right, you get back to the previous line. This multiplies in to give you that. And then I like to call it double factoring because you end up
Yeah,
you're
yeah,
grouping, but you're factoring again at least twice.
yeah,
You'll
because it's
notice,
x cubed minus 8, which can be put more down.
yeah,
Yeah.
it's a difference of cubes, so it's kind of another nasty, got a lot going on to solve it. And yeah, it's just there's just a lot. And like I said, you can eventually pattern the answers for this last part. Like I would actually ask my teacher, hey, can I just like memorize the answer to this always? She might say yes.
Okay, so then in this case, it would be x equals -5 and x equals 2, and then for the other one, it would be x squared. Two. All right, I got -2 plus or minus the square root of 4, -4.
No. So that it's 2 squared minus 4 times 1 times 4. It always ends up being not, it's never a perfect square. In this case, you got 2 root 3 or 2i root 3 over 2. So take just another look at that.
Oh, yeah, I see where I got. Okay, I might have made a mistake. Yeah, somewhere in some of the calculation, I think that's where I made the mistake. Simplifying inside the. Uh,
Yeah, I mean, there's a lot here. There's a lot of ways to go wrong. Only one way to go right. So you got to be really careful on these. Anything else I can quickly answer for you?
plus, plus, one. Yeah, I think that's all on this lesson. I did look a little bit ahead before the session, and I did see that it's 4.5 is factor to graph, as in you follow all the steps that we've learned so far, like
Yeah,
the factoring and all that.
yeah,
So
yeah. The expectation is that you can do a graph from just the polynomial, no calculator, find all the roots, y-intercepts, other things like that.
yeah, so definitely if I have any questions, I might schedule a session over the weekend. But yeah,
Sounds good. I'm getting a little bit more, I'm gonna get busier, so just if you don't see something you like, just let me know. Happy to schedule it manually for you if I got the time.
All right.